We see this number everywhere, from sports stats to economic reports. It's the average. But this number, also known as the mean, has a hidden flaw that can be incredibly misleading. By the time we're done here, you're going to know exactly when to trust it and when to be very, very skeptical. So to get started, I've got a little puzzle for you. I'm going to show you two groups of students, and all you have to do is figure out which group is smarter. Sound simple, right? Well, let's see. All right, so which one is it? Class A or Class B? I'm about to show you their individual IQ scores. Get a guess ready in your head. You got it? Okay, let's go. Okay, so here's Class A. We've got 13 different IQ scores, ranging from a high of 140 all the way down to 89. Can you really get a feel for the group as a whole just by looking at this? It's tough. It's really just a jumble of data. And now here's Class B. Again, 13 scores, this time with a high of 162 and a low of 80. Trying to compare this list to the last one in your head? It's a total headache. It's confusing. It's inefficient. There has to be a better way. And yeah, of course there is. Instead of getting totally lost in all those individual data points, we can boil all that noise down into one single powerful number for each group. And boom, here it is. The average IQ for Class A is 110.54. For Class B, it's 110.23. Instantly, everything just snaps into focus. All that confusion we had looking at the raw numbers, it just melts away. So what does that tell us? They're basically just as smart. The difference is so tiny, it's not even worth talking about. A question that was nearly impossible to answer a second ago is now solved in a split second. That's the power of a single representative value. Now, this incredibly useful tool actually has a formal name in statistics. It's called a measure of central location. And honestly, it's exactly what it sounds like. It helps us find the center of our data, the point where all the values tend to cluster, giving us one number to represent the entire set. Now, to be clear, the mean isn't the only game in town. There's also the median, that's the middle score, and the mode, which is the value that shows up most frequently. But for today, we're focusing on the big one, the most common, most powerful, and as we're about to see, the most dangerous of them all, the mean. All right, so we get why the mean is so useful, right? It simplifies things. Now let's pop the hood and see how it's actually calculated. Don't worry, it is remarkably simple. It's really just a simple two-step process. First, you add up every single number in your set to get a grand total. Second, you divide that total by the number of values you have. That's it. Sum, then divide. Let's walk through it with a new example. Here we have the monthly salaries for 14 employees at a company. We can see some people making 10K, a few at 15K, and someone at the top making 25K. Let's find the mean salary for this group. Okay, step one, we add all 14 salaries together, which gets us to 251,000. Then, for step two, we divide that sum by the number of employees, which is 14. And there's our answer. The mean monthly salary is $17,900. And, if you look back at that list, that number feels about right. It falls nicely in the middle of the range of salaries. It feels representative. Just a quick side note here. You might see different symbols for the mean, like the Greek letter mu or an X with a little bar over it. Don't worry about it. They're calculated the exact same way. It's just a way for statisticians to show if they're talking about the average for an entire group, a population, or just a small sample of that group. So the meme seems fantastic, right? Simple, powerful, useful, but this is where our story takes a sharp turn. This tool has a fatal flaw, one that can turn a helpful number into a complete lie. Let's call it the billionaire problem. Okay, let's go back to our 14 employees and their salaries. Now imagine a new employee joins the team, a 15th person. I mean, how much could that one person really change the average? Well, what if that new employee has a monthly income of $695 billion? This is what statisticians call an outlier, a data point that is just wildly different from all the rest. And outliers are the mean's worst enemy. So let's do the math again. We take our original sum of 251K, add this mind-boggling $695 billion, and now we divide that whole thing by our new total of 15 employees. And here is the problem. The new average salary is $46.3 million a month. It went from a reasonable $17.9 thousand all the way up to over $46 million because of one person. Does this new average represent anyone in the group? No. not the original 14, and not the billionaire. It's become a useless, misleading number. Imagine the company putting out a press release with this quote. The thing is, it is technically, mathematically, 100% correct. The mean salary is $46.3 million, but it paints a picture of reality that is a complete fantasy. And this is how statistics can be used to lie. Okay, so let's wrap this up by summarizing what we've learned. The mean is a tool, and like any tool, it has its strengths and its weaknesses. The key is knowing when to use it, and probably more importantly, when to question it. On the plus side, the mean uses every single piece of data. Nothing gets ignored. But that's also its biggest weakness. It is extremely sensitive to outliers, as our billionaire just showed us. One extreme value can just drag the entire average off a cliff, making it totally unrepresentative of the very group it's supposed to describe. And this leaves us with a critical question. If the mean is so easily broken by a single outlier, what are we supposed to do? I mean, when we're looking at things like income or house prices, which often have these extreme values, what tool gives us a truer picture of the center? Well, we'll explore that very question in our next explainer.